Welcome back, statistics scholars. This is our last discussion for the whole semester. And it's essentially, how do you know what analysis to do? In an actual practical research situation, no one is going to tell you. And so the last thrust of the class, which hopefully I've been preparing you for this whole time, is about reading a short research situation and knowing which analysis to do. So a non-trivial amount of your final exam is going to be doing just this, reading very short research scenarios and deciding which analysis to do, sort of like we did in our last exam, except you only had to decide between z-tests and t-tests. Now we're going to need to look at all of the tests that we've done so far and decide which test should we do. And so let's go over all the possible tests that we've done all semester. The last ones we went over just last time were the chi-square goodness of fit test and the chi-square test of independence. We started our journey with a one-sample z-test, then we moved on to the one-sample t-test, then we learned about the independent samples t-test, the dependent samples t-test, the ANOVA or f-test, the correlation, and regression. And so the way you break down, the way you know what test to do is asking yourself this question. Am I dealing with quantitative or categorical qualitative data? That is the big question to ask, and why I kept trying to drive home how each and every analysis related to the type of data that we had. So for example, a chi-square goodness of fit test is the kind of test you can do if you have one categorical variable and you're asking if there's the same number of people in each category. Like for example, I want to know if there's an equal number of people who like Pepsi, Coke, and Dr. Pepper. In reality, I'm actually looking to see if there's unequal numbers of people. Is there a preference among the categories, right? One categorical variable. Are the people evenly distributed among the categories or aren't they? Or I may say there's 4 different favorite colors in class, blue, green, red, and black. And I'm wondering if there's a preference among those 4 different favorite colors, or if one group or more than one group has different amounts of people in them. A chi-square goodness of fit test. To use that example from class, we looked at Monarchs versus Brahma fans, and we found out that there was a preference for Brahmas versus versus the Monarchs. A chi-square test of independence is when you have 2 category-based, group-based variables, where you ask the question, is there a relationship between these 2 categorical group-based variables? So if you have one group-based variable, it's a chi-square goodness of fit test. If you have 2 categorical variables only, then it's a chi-square test of independence. But then to go all the way back to the first analyses that we did the one sample Z or the one sample T test, and they were very similar. It's just in a one sample T test, we had to estimate standard error. Well, you knew you were doing a one sample Z or T test if you had one sample with quantitative data, because then you compared it to a known population. You had a known population average that you compared your one sample to on some quantitative more versus less, higher numbers mean more, lower numbers mean less type of variable. That was going to be a one sample Z or T test. And on the exam, for this portion of the final exam, I'm not going to make you choose between the Z or T test, the one sample Z or T test. You may have review questions from the third exam that asks you to choose between the Z or T test, but when you're reading these short research scenarios, and it's clear you only have a single quantitative variable, you're only going to be required to know that this is a one sample test, either a Z or T test. And you're going to know that because it's going to be describing one sample with one quantitative variable that's being compared to a known population average. An independent samples t-test, you are going to have both a categorical variable or a qualitative variable that has 2 groups and one quantitative variable where you're comparing the 2 averages from the 2 groups on the quantitative variable. That's how you know an independent samples t-test when you see one. You've got 2 groups, where you're asking, are these averages the same or different? Where it's clear you have two samples of individuals. The dependent samples t-test, you're going to have a categorical variable. You're going to have a quantitative variable, but you're going to be comparing the groups that are related to each other in some fashion. Paired groups, like the differences between older twins and younger twins, or the differences between brothers and sisters, or the differences between husbands and wives, mothers and daughters, that kind of thing. Or the differences between a single person's score on day one and a single person's score later on. An ANOVA is when you have a categorical group-based variable, but you have more than two groups. More than two groups, where you're comparing the averages of those three or more groups. So you have a categorical variable and a quantitative variable, but the number of groups you have on your categorical qualitative variable is 3 or more. The correlation is when you have two quantitative variables and you're asking, is there a relationship between these two variables where the variables are quantitative, more versus less? A regression is just like a correlation, except used with prediction, right? So that word prediction is going to be important to help identify a regression. Two quantitative variables, sure, but in addition, you're using one variable to predict the scores on the other. So let's go through some examples of these and I'll break down how I figure out what kind of analysis I need to do to help prepare you for on the final. When I give you similar research scenarios, you can figure out what analysis to do. So, a psychologist wants to compare the anxiety among freshmen, sophomores, juniors, and seniors, right? The psychologist selects 200 students in the class and the psychologist selects 200 students in the class and gives them an anxiety inventory that ranges from -50 to +50. What analysis would be appropriate for this test? Well, automatically I see I have 4 groups. So I have one categorical variable, one qualitative question where I ask people, what year in school are you? Are you a freshman, sophomore, junior, or senior? Right? And so I have one categorical variable with 4 groups. But is there a second variable? Yes, there is. It's anxiety. And I've made it very clear that I've measured anxiety from more, 50, to less, -50. So I have one group-based variable, one category-based, one group category-based variable, and one dimension-based quantitative variable from more to less. But I have more than 2 groups. I have 4 groups. Got to be an ANOVA. Has to be an ANOVA because I have 4 groups, but I'm comparing the average anxiety, more versus less, for these 4 groups. Got to be an ANOVA. Predicting the number of written items correct on an exam from the number of multiple choice items correct. Well, let's see. How many variables do I have? The number of written items correct. That sounds like a variable from more to less. The number, right? More items correct, less items correct. So I have the number of written items correct, and then I have additionally the number of multiple choice items correct. So I have 2 quantitative variables ranging from more to less. Well, if I have 2 quantitative variables, it's either going to be correlation or regression. Well, here's that word predict. It's got to be a regression. So, the next one, do more men than women choose to study engineering? So how can I break this one down? Well, I certainly have gender as a variable, men versus women, but is there something else here? Well, I have this second thing called choosing to study engineering. Well, that sounds like a choice of yes or no. So I've got gender, men versus women, and studying engineering, yes versus no. So I have 2 variables, and they both sound like group-based variables to me. They both sound like categorical variables. So it's going to be a chi-square test of independence. Because if you have 2 qualitative variables where you're asking if there's a relationship, men, gender, and the relationship to whether or not they choose to study engineering, that is going to be a chi-square test of independence. But how about this one? Do men and women have different heights? Well, gender is certainly a variable again, but height. Well, height's going to be measured from more to less. So I have a qualitative variable, a group-based variable with two groups, where I'm comparing the averages of these two groups. And men versus women, that doesn't sound like people I'm going to have to pair up. So not a paired samples t-test. I'm not talking about any known populations. So it's got to be a independent samples t-test. Two groups where I'm comparing their averages on a quantitative dimension, height, and where I'm not pairing them up in any meaningful way like husbands and wives. So it's going to be a independent samples t-test. How about this? Are those under 20 more adept at using their laptops compared to those over 60? Well, age is normally a quantitative dimension, but what I'm treating age as here as a group, right? Those under 20 versus those over 60. So I'm creating two groups. So I have at least one group-based variable. But what about this other part of the question? More adept at using their laptops. Well, this word more is a key, right? More versus less. So again, I have two groups, the over 60 set, the under 20 set, where I'm comparing them on adeptness, more versus less. Got to be an independent samples t-test. Two groups where I'm comparing them on something quantitative. And so how about this next one? Does online gaming usage differ among people of 4 different ethnicities? All right, well, I've got 4 groups, right? So 4 different ethnicities on one categorical variable. The one categorical variable is ethnicity, 4 different possible outcomes, 4 different groups. And now I have online gaming usage. Well, so I'm probably looking at online gaming usage more to less. Does the online gaming usage differ among these 4 different ethnicities? Online gaming from more to less. How many hours do you spend online gaming, right? So it's going to be an ANOVA, right? People of 4 different ethnicities. I've got more than 2 groups, 4 groups, comparing them on some quantitative dimension. Online gaming, more versus less, got to be an ANOVA. Do physics students do better on biology than biology students on calculus exams? Well, physics students versus biology students certainly sounds like a group-based variable to me. Are you this major or that major? Group-based variable, categorical, qualitative variable. Calculus exams, on the other hand, scores on that would certainly be quantitative. Last time I checked, most exams are more versus less, right? So I've got 2 groups where I'm comparing them on something quantitative, some average calculus exam grade. Got to be an independent samples t-test. Is there a relationship between blondes and brunettes and the decision to dye one's hair? Well, let's see. Blondes versus brunettes, group-based variable, at least one categorical variable. The decision to dye one's hair or not. That also sounds like a categorical variable to me, right? Dyeing one's hair or not dyeing one's hair. Are you a blonde or are you a brunette? 2 categorical variables, has to be a chi-square test of independence. Or how about this? Can you predict hours spent studying from anxiety scores? Hours spent studying is certainly quantitative. Anxiety is probably measured quantitatively, more anxiety versus less. And I've got that word prediction there. I've got 2 quantitative variables where I want to use one variable to predict the other. Got to be a regression. How about this? What is the relationship between the number of hours spent studying and the number of pages assigned for reading? I have 2 quantitative variables. The number of hours studying, more to less. The number of pages assigned, more to less. But I don't use that word predict. Got to be just a correlation then. Or how about this? Do out-of-shape men spend an unusually large number of hours watching sports? Well, it sounds like I only have one group of out-of-shape men. One group of out-of-shape men, and I'm seeing if they do something a little different than what I clearly already know. Spend an unusually large number of hours watching sports. Sounds like a one sample Z or T test to me, where I've got one group of out-of-shape men that I'm measuring how much they spend time, how many hours they spend watching sports. Now, on your final exam, if it's going to be a one sample Z or T test, I'm going to give you some indication that the group is being compared to something already known. I'll use the word population. I'll say compared to the already known value. Here is a little more murky, but on the final exam, it will be explicitly clear. Do out-of-shape men spend an unusually large number of hours watching sports compared to some known average is something I might say on the final, where you will know it's either a one sample Z or T test. How about this one? Predicting height from weight. Height is quantitative, weight is quantitative, and there's that word prediction. Got to be a regression. Do wives do more house cleaning than their husbands? Well, wives versus husbands sounds like a group-based variable to me. More versus less house cleaning sounds quantitative. So I have two groups that I'm comparing on some quantitative outcome, but I'm comparing matched pairs, husbands versus wives. Got to be a paired sample or a dependent samples t-test. Remember, those are just synonyms for the same analysis. Paired or dependent samples t-test. Or how about this? Does online gaming usage differ between people of different professions? Well, there's probably more than two different professions. Online gaming is probably measured quantitatively, more gaming versus less gaming, right? So I've got more than two groups. Doctors, lawyers, people of different professions, teachers. So I've got more than two groups where I'm comparing the average amount of online gaming usage. More than two groups, comparing their averages on some quantitative variable, gotta be an ANOVA. So here's something a little more nuanced. Suppose you're interested in whether liberals and conservatives will be more forgiving of a liberal politician. Well, liberals versus conservatives, clearly I have a group-based variable with two groups. But let's read on. You hypothesize that liberals will be more forgiving. After collecting the ratings from 56 liberals and 48 conservatives, you find that liberals have a mean forgiveness score of 27.5 and conservatives have a mean forgiveness score of 18.1. Well, automatically I see I have averages here. I'm comparing the averages of two groups. Got to be an independent samples t-test because I'm not going to pair up the liberals and conservatives. They might find that kind of annoying. I'm comparing an independent sample of liberals to an independent sample of conservatives. Independent samples t-test. Or how about this? Do pre-law students have higher scores than pre-med students on the SATs? Well, I've got two groups on a quantitative variable. One variable, are you a pre-law or a pre-med student? Two outcomes, pre-law, pre-med, but I'm comparing them on some quantitative dimension. SAT scores. Got to be an independent samples t-test. How about this one? Is there a preference for vanilla versus chocolate ice cream in this class? So think about what I'm asking everyone in this class. I've got one group of people in this class, and I'm asking everyone to choose. Do you like vanilla? Do you like chocolate? Do you like vanilla? Do you like chocolate? It's going to be a chi-square goodness of fit test because I have one variable. In this class, is there a preference for vanilla or chocolate? You got to choose, right? Chi-square goodness of fit test because I have one variable, one way that things can be different, and it is a group-based variable. Are you vanilla or are you chocolate? Or how about this? Is there a relationship between those over 6 feet versus under 6 feet and the decision to choose basketball as a hobby? Well, I've got a categorical variable. I'm treating height, oddly, in this example, as a category-based variable. I'm looking at over 6 feet people and under 6 feet people. I'm choosing to measure this as a category, as a group-based variable. So I've got one category-based variable at least, over 6 feet, under 6 feet. And then I'm also looking at the decision to play basketball. And it sounds like I'm doing that from more to less. Excuse me. Sounds like I'm doing this. Do you do it or not? Do you choose to play basketball or not? So I've got over 6 feet, under 6 feet, category-based variable. Do you play basketball or not? Category-based variable. Two categorical variables, two group-based variables. Got to be a chi-square test of independence. Or how about this one? Can you predict the hours spent studying from previous exam grades? Well, hours spent studying, that's going to be quantitative, more to less. The answer to the question is going to be a number. How many hours did you spend studying? Previous exam grades is also going to be quantitative from more to less. When I ask you, how many points did you get on the last exam, you're going to give me a number. And I've got that magical word predict, two quantitative, more versus less variables, where I use that word prediction, got to be a regression. How about this? Are firstborn children smarter than lastborn children? Well, firstborn children versus lastborn, it certainly sounds like I'm going to be pairing people up. Pairing up siblings, firstborn children versus the lastborn children. And I'm comparing them on intelligence, which we know to be a quantitative dimension. So I'm pairing people up in two groups, firstborns, lastborns, and comparing their averages on something like intelligence. Got to be a paired samples t-test. How about this? What is the relationship between the number of hours exercised and weight loss? So I'm looking for the relationship between two quantitative variables. The number of hours you spend exercising, that is a quantitative variable from more to less. And weight loss, that's also going to range from more to less, quantitative variable. Two quantitative variables where the answer to the question is a number. How many hours did you spend exercising? 5, 6. How much weight did you lose in the last month? 3 pounds, 4 pounds, 5 pounds. Two quantitative variables. What is the relationship? Got to be a correlation. But I might ask the same question this way. Is there a relationship between the number of hours exercising and weight loss? It's still going to be a correlation-based question. Or how about this? Do personal injury lawyers score lower on ethics exams than the population of lawyers in general? So it looks like I'm comparing one sample of personal injury lawyers to something I already know, the population of lawyers in general, where I'm looking at the scores on an ethics exam. So I've got one sample of personal injury lawyers and their responses on a quantitative variable, an ethics exam, where I'm comparing it to a known population. Got to be a one sample test, either a one sample Z or a one sample T test. Or how about this? Is there a preference for red, blue, or green? Is there a preference for red, blue, green, black, or purple backpacks on campus? So think about this variable. I'm asking you, I'm going to go around campus and ask people, what is your favorite color backpack? I'm only asking everybody one question, right? I'm walking around campus and I'm asking everybody one question. Hey, what's your favorite color backpack? So I've got one variable. What kind of variable is it? Well, it's qualitative. It's categorical. Because when I ask people this question, what's your favorite color backpack? The answer to my question is going to be a word. People are going to say red, blue, green, black. Well, if I have one variable that is group-based, category-based, it's going to be a chi-square goodness of fit test. Next one. Is there a relationship between gender and one's favorite television show? So imagine yourself walking around asking people these questions. First, you have to ask people what? You have to ask people their gender. And so that is going to be a group-based variable. Male, people are going to say, I'm a man, I'm a woman, I'm intersexed, I'm gender fluid, I'm something, but the answer is going to be a word, right? And so that is going to be a group-based variable. And then you're going to also ask them a second question. What is your favorite television show? That is also going to be a word answer. They're going to say Doctor Who or Jessica Jones or, I don't know, some reality TV show. Who knows? But they're going to give you a word as an answer. And so you have two variables that are both category-based variables, categorical qualitative variables. Two variables, both categorical or qualitative, has to be a chi-square test of independence. Predicting future exams grades from the hours spent studying. That's just me rephrasing one from earlier in slightly different language to point out we can still break it down. Predicting your future exam grades, well, that's quantitative. From the hours you tell me you're going to spend studying, also quantitative, where I'm making a prediction. Got to be a regression. But I might say it this way. Can you predict future exam grades from hours spent studying? It's still a regression-based question. So don't get tripped up on the language. The way you break them down is asking, what questions are you going to ask people? If I ask you about your hours spent studying, that's quantitative. If I'm trying to determine Your exam grades in the future, that's quantitative. If I use that word prediction, it's regression. Here's a slightly more nuanced one. A psychologist creates a brand new therapy for depression. Because it has never been used before, she is not sure what effect it will have. She decides to see how it compares to the current therapy as well as a placebo. So what do you think is going to be the best analysis? Well, depression is almost certainly a quantitative variable. She's going to be measuring the average amount of depression, right? So you have a quantitative variable of depression, more depression versus less depression. And she's going to be comparing the depression among 3 different groups. Boom, got to be an ANOVA. I have a qualitative variable. What drug did you get, right? I have the therapy, placebo, pardon me. So you've got 3 different groups. You've got a brand new therapy, you have the current therapy, and you have a placebo group. You have 3 groups, boom. You're comparing the 3 groups, the average depression among the 3 groups. You have a quantitative variable as well. A group-based variable, what therapy did you get? The group-based variable has 3 groups, and now you're comparing the 3 groups on something quantitative, where you would reasonably get an average depression. If you compare the averages of 3 or more groups, got to be an ANOVA. Or how about these ones? What is the relationship between anxiety and depression? Is there a relationship between anxiety and depression? Both of these 2 questions are just 2 ways of phrasing the same kind of idea. Because again, don't get tripped up on the language. If I have anxiety as a quantitative variable, more versus less anxiety, depression as a quantitative variable, more versus less anxiety, and I don't use the magical word prediction, it has to be a correlation. How about this one? Do surgeons make more than doctors as a population? So I'm telling you that I know how much doctors as a population make. And now I'm going to compare one group of surgeons to this known population. And I'm comparing their average money, right? Got to be a 1 sample Z or T test. How about this? Does listening to music or not impact test performance? So I have a group-based variable. Do you listen to music or not? But I'm comparing these 2 groups, and it certainly sounds like independent groups. Do you listen to music or not? I'm comparing their test performance, which is a quantitative variable, more versus less. So I have 2 groups, and I'm comparing the average test performance for the 2 groups. Got to be an independent samples t-test. Or how about this one? Does listening to classical music, rock music, or silence impact test performance? Well, now I have 3 groups where I'm comparing the average test performance. Got to be an ANOVA. How about this one? Are liberals and conservatives different in their ratings of how humorous a comedian is? Well, now I have 2 groups. They sound like independent groups, liberals versus conservatives, but what am I going to be asking them, right? I'm going to be asking each of them, are you a liberal or a conservative? Certainly. That's a qualitative variable. But I'm also going to be getting how their ratings for how funny they think some comedian is. Maybe I'm having them rate Trevor Noah. Maybe I'm having them rate Jon Stewart. Maybe I'm having them rate, I don't know, old Eddie Murphy movies. Who knows? But I'm getting their ratings for how humorous. More versus less. More humorous versus less humorous, right? I have 2 groups comparing their average humor ratings. Got to be an independent samples t-test. And here's one last one. A little more nuanced. A psychologist believes daily multivitamins impacts well-being levels. On a national survey, the mean well-being level for those who take vitamins is 126. So I know this ahead of time. For a sample of 97 participants who take the vitamins for 3 weeks, the average well-being score is 156 with a standard deviation of 34. What test should I do? Well, I know the average well-being for the population, and then I know this one sample's average and one sample standard deviation. Has to be a 1 sample t-test, right? Because I have a known population average, but not a known population standard deviation. And I just saved this one for last because I'm going to, again, point out that on the new material, the brand new material, I'm not going to make you decide the difference between a one sample Z or T test. But there may be review items from the third exam that asks you to do that. So I do want to point out to you that the only difference between a one sample Z or T test is whether or not you know the population standard deviation. And in this example, we do not. So I have two versions of these lecture notes online. I have some without the answers that I just went through just now, and I have some with the answers so that you can sort of test yourself. And I would encourage you to come up with your own research questions that you think falls in to each of these different types of research scenarios. And the key is, how many variables do I have, and are they qualitative or quantitative? And I promise you on the exam, I will make it unambiguously clear whether or not each of the variables is a group-based variable, qualitative or categorical, a group-based variable, qualitative or categorical, and I will make it explicitly clear if the variable is quantitative, ranging from more to less. And so you just ask yourself this question: one categorical variable, good as the fit test. Two categorical variables, chi-square test of independence. One quantitative variable where you're comparing it to a known population, something you know ahead of time, a known average, a one sample Z or T test. One categorical variable with only two groups, and one quantitative variable, independent samples T test, where the groups are independent, clearly not related to each other. One categorical variable with two groups and one quantitative variable where it's clear that the two groups are paired up, has to be a paired sample or a dependent samples t-test. If you have one categorical variable, one group-based variable with more than two groups, 3 or more, and one quantitative variable, has to be an ANOVA. Two quantitative variables where you simply are exploring the relationship between the two quantitative more versus less variables. Got to be a correlation. If you have two quantitative variables where you're using one to predict the other, it has to be a regression. All right. Good luck. I thank you so much for a great semester. I really want to thank everyone for how hard you all worked. I really appreciate it. If you have any questions regarding this or any of the new material running up to the final exam, please let me know. As a reminder, the final exam is a closed book, closed note, closed internet exam. So please keep that in mind. As you're taking the exam, you will have more time to take the exam than the in-person folks get. But do time yourself, do pace yourself, because it's a 100-point exam. There will be 25 old multiple choice questions from the previous exams. There will be 25 new multiple choice questions that cover ANOVA, correlation, regression, and chi-square. There will be 25 old essay or calculation questions from previous exams, and then there'll be 25 new calculation questions. No new essay questions, so I'm sure that makes many people happy, but there will be 25 points of new calculation, calculating ANOVA, calculating correlation and regression, and calculating chi-square. And then, just like we did today, there will be some short research scenarios that you will have to choose the appropriate analysis to do. And the way you break it down is by asking, how many variables do I have? And are they categorical or quantitative? And how many groups do I have? It's just that simple. If you have any questions, please email me or post in the Q&A forum. Thanks so much. Have a good one.